Although most teams want to use generative AI effectively, they end up stuck with generic outputs from models that power popular tools such as Copilot and ChatGPT. To get the most out of these generative AI models, you typically have to fine-tune them. Now, fine-tuning is the process of taking a pre-trained model and giving it examples for a very specific task. This can actually make a smaller model work as well as, or better even, than a larger model on that specific task. Now, this is actually important for an enterprise because if you're serving a lot of users, whether it's outside, such as your customers, or internally, such as your employees, you want a model that's not only fast, but cheap to run, and optimally open source, so you're completely in control. When it comes to actually creating a fine-tuning data set, this can actually be a problem more of effort and less of the data itself. Most businesses actually have the data to fine-tune a model, whether it's in the skills and expertise of the employees or it's locked in the documents such as PDF and Word files. But to take that data, whether it's in the employees or the documents, and put it all together to actually create a data set to fine tune, that can be a lot of effort. And sometimes it just doesn't make sense based off the riskiness of fine tuning a model. It may or may not work. So sometimes an AI project just doesn't get approved. Or if it does, so much of the time allotted to the project is just spent on creating the data set that you can't really get the full scope of capabilities of actually creating an AI agent within that time. So this is a problem I've seen come up many times in previous AI projects I've done over the years. So I want to build a tool that addresses it specifically, and I call that tool DeepDeliberate. Now, the reason for the naming of DeepDeliberate actually comes from the DeepSeek model. So DeepSeek R1 is, at least for me, the first time I saw enterprises overall really look at these open source models and think of how they can be competitive with the closed source models, which for most of the previous generative AI, let's say, era have been at the forefront. And there's been a really big difference between open and closed source, which is now recently closed or mostly closed. And I wanted to think about how we can use these open source models such as DeepSeek R1 and have it work effectively for synthetic data generation. So for this project and for the demo I'll be showing later, I use DeepSeek R1 0528, which is the upgraded version for tool use specifically. And it's hosted on Microsoft Azure, so it's a trusted cloud provider. And the whole point of using these agents is to create realistic, essentially conversations between a user and the assistant. And the way I do that is using a multi-agent simulation. So there's three agents. The first one is a generator agent, which creates queries in a way that would be similar to how a customer or an employee would create it. So in the demo I'll be showing it's a customer service chatbot. So let's say the generator agent is a frustrated customer and they're asking a question. They're saying, I'm trying to make a return, but the portal's not working. I'm really frustrated, so on and so forth. So just like a negative output. And then when it comes to the assistant agent, which is supposed to act as your customer service chatbot, that agent is supposed to reply in an empathetic and helpful tone, and it might use tools to answer the customer's questions. So let's say retrieval augmented generation to search up the return policy, or using an MCP server as a tool call to update a CRM such as Salesforce and HubSpot, and doing all these things together to give the customer the best experience and most helpful experience. And then you have the third agent, which takes the conversation between the generator and the assistant that I just discussed and ranks it based off the key performance indicators, such as the appropriate tool use based off the context of the conversation, the tone of the customer service chatbot. So was it empathetic enough? Did it address all of the questions that the customer had for it? These type of things that are, you can't really hard code. They need another AI model to be in the loop. That's what the judge agent is for. So you have three agents, the generator, assistant, and judge, and the three of them work together and create multiple examples. And the best way to do this might be in batches. So let's say you have a batch of 100 conversations with a very specific persona configuration. So frustrated customer for one, helpful agent for the other that uses a very specific set of tools. And that's the first 100 in a batch. And then you might have another batch of 100 calls, but here you make it an annoyed customer, like you change up the persona and you change up the persona of the agent as well to give it more dynamism and essentially cover the different edge cases. So this is how I kind of thought of DeepDeliberate, where you're using the full power of large language models to work in very gray areas in ways that we can't really do with hard coding these systems. So DeepDeliberate is meant for creating those examples. And it's not perfect. Obviously, large language models aren't going to perfectly simulate real-world data and use cases. But it's meant to create that first data set so you can get started and actually build something in terms of a minimal viable product or something for a pilot. and then iterate on that over time as real user input comes in. That's the scope of DeepDeliberate. It's a research project. It's not meant for production use, at least not at the current iteration of it. So I'm really interested to see how people in the community, such as LinkedIn and others, will think of this project and perhaps use it for their own research or for their enterprise use case. So I think that's enough said in terms of the goals of the project, and now I'll switch into the demo. Okay, so now we're at the exciting part, which is the actual demo. So here you'll see on screen essentially the command to trigger DeepDeliberate. And there's a few key things I want to bring your attention to. So first you'll see the main orchestration script, which is the deepdeliberate.py file. And then you'll see essentially a file path towards the specific agent that we're testing, in this case, or that we're using. And this would be the assistant agent in our three agent simulation. So under setup agents, and then you'll see the customer service agent.py. So this actually has the persona of the customer service agent. And then you'll see the mode is approve, and there's another mode called auto, and I'll show that after. But essentially the difference between both of these is that approval will require my manual approval at each step of the simulation, where auto just does the entire process step by step automatically without my interference. And then the configuration, this is for the actual generator agent. So under configuration, you'll see we're using the customer service configuration, which is in the JSON format. And particularly under this configuration, which has multiple personas, we are using the frustrated customer persona. So here you can see in one line, everything's configured in a very specific way. And then you have count, which is 1. And this just means how many conversations or examples DeepDeliberate is generating. In this case, it's just 1, but this could be 10, 100, 1,000, however many examples you want. And especially if you're running this in auto mode, you can just essentially set and forget, where you can just turn it on and have it run through the multiple examples, and then just come back when everything is done. So this makes it ideal for generating synthetic data in terms of how DeepDeliberate has been built. So now I'll just click enter to get things started. So we're connecting to Azure. Let me just turn that zoom off. And now we can see that DeepSeek R1 hosted on Azure is generating the query. So this is the generator agent in our simulation. And I should note that these can take some time each step, just because, especially for the DeepSeek models, we're not only recording the output, but also the chain of thought. So first, the agent is generating its entire chain of thought, and then we're also getting the output. So you'll see here the generated query. This is the frustrated customers essentially line where they're saying, what the hell, I just saw a $15 charge on my bill. So this is the frustrated customer. And then this is the whole reasoning of why we got this output, which is DeepSeek's reasoning. So we're generating a query for the frustrated customer persona. The scenario is complaining about being charged for security monitoring. So this is the whole essentially chain of thought of why it did what it did. And then we have all this metadata that can be useful later. So here, and you can see the choose the action. I can either continue, repeat this example, or exit. So I'll put C for continue. And next step, we have O4 Mini, also hosted on Azure. This is the actual assistant agent here, which is the helpful AI chatbot. And you'll see interestingly here that we don't have the chain of thought, and that's just because O4 Mini, as a closed source model from OpenAI, doesn't reveal the full chain of thought. This is in contrast to the generator and assistant models, or generator and judge models that are DeepSeek based and have the full chain of thought. So this is one thing you might want to consider if you're testing different agents, is what is the underlying model. So, and you'll see here it gives a very, I think, reasonable response of, hello, I understand your frustration, seeing an unexpected charge, so on and so forth. So now I'll continue, and this is when we have the judge agent evaluate the response. Again, this is using DeepSeek. And this part can actually take some time, just because for the judge agent to evaluate everything, it's reading the chain of thought and the output of the generator agent, which is the first one that we saw. It is also reading the example or the response from O4 Mini here, which is the assistant agent. Then it's considering, okay, is this matching the KPIs that we've established? And it's writing out the entire chain of thought. and then it's giving out the final answer. So you can see how it took some time to give back its answer. So these are very general scores just for this demo purpose. This isn't very reliable, so like accuracy, relevance, completion. This is I just gave as a prompt to DeepSeek and said, hey, can you check according to this criteria? But really, you'd want to be very specific and perhaps use other tools to actually do this evaluation. But again, for this purpose of this demo, I just kept it very simple. So I'll now just continue, and we have the entire session data. So approved mode was used. We have one completed interaction, and the average is 100%. Obviously, nothing is 100% real life, but for this purpose, it is. So now I'll actually show you the auto mode. So I'll just go through a few of these here. There it is. So again, here you can say mode is auto. So I'll just click 1, and you'll see now DeepSeek query is being generated, and I'm not doing anything here. It's just all going on its own. So DeepSeek will give its answer. So now I didn't click continue or anything. You can see automatically the assistant agent, which is O4 Mini, is going to give its response. And then right after that, you'll see the judge agent give its evaluation. So there we have the second agent has responded, and now the evaluation is being done. And we're just, I'm not touching the keyboard at this time. Everything's just running automatically. And you wouldn't even have to have this in a GUI like you would, or in the command line here. You can run this in the background just because it does, if it's just auto mode, you don't need your approval. So you can set this overnight, and essentially by the time you wake up, you can have hundreds, thousands of examples done for your synthetic data generation, which is a really powerful use case because you don't have to be so manually involved in the generation process. And this part, you'll see it does take some time just because it is evaluating so much context. So we'll just give it a second, and there we are. So the mode was auto approve. This evaluation score is a bit less at 95%. And we have our session data key, and we have essentially the metadata of the entire session. So that is essentially DeepDeliberate. That's what it looks like in both the approved mode, which is manual, and the auto mode, which just runs completely autonomously. And I hope this gives you a good insight into how DeepDeliberate can help you generate synthetic data. And I'd love to see how others use DeepDeliberate to help them. Thank you.